In this video, I'm going to explain the scientific method and some basics about how to design your experiment. The scientific method was supposedly developed initially by this guy, Francis Bacon, and basically it has these 6 steps. First, you come up with a research question, then do background research on that topic. Then you take that information and construct a hypothesis. Finally, you collect data with an experiment, then analyze the data and draw conclusions. And then the last step is to report your findings. In this video, I'm going to explain each of these steps one by one. So let's get started. The first step is to come up with a research question. Now, in my example, I decided that I like to drink coffee, and I like to drink coffee while I'm working. I think coffee makes me work better. So I'm kind of interested in something like this, which is, does coffee, or really caffeine, does caffeine help to improve people's concentration? So now we move on to the second step, which is to do background research. In this step, you look for published research papers about your topic, and you read them to learn about it. You have to be careful. The experiment that you want to do might already have been done. Maybe we already know whether caffeine improves concentration. So I need to go and read some papers to find out. So just to give you an example, I found a couple papers here, the effects of caffeine, sleep loss, and stress on cognitive performance. So I read through this paper, and for example, I'm not going to go through every detail here. But one thing you'll find here is that caffeine's effects are near maximal 1 hour after administration. So that's something that I need to know, that 1 hour after drinking the coffee is when I should get the maximum effect of the caffeine. Another paper that I found is this one, Regular Caffeine Consumption, a Balance of Adverse and Beneficial Effects. One of the things that I found in this paper is that it basically is saying that caffeine does improve response time on these kind of tests that they had people do, but that it seems that it's not so much that caffeine improves your performance, it's that people who usually drink coffee, who drink coffee every day, they have worse performance when they don't drink caffeine. So that's something else I need to know to construct my experiment. Okay, so now I go back to my notes, and here I just wrote down some of the things that I learned from the reading. Okay, so now we can move on to the next step, which is after we've collected our information, now we can go to construct a hypothesis. Now our question was, does caffeine help to improve people's concentration? But what we need to do next is to make a testable question. Well, how do we measure people's concentration? We have to find a particular way to measure concentration, some aspect of it that we can actually measure. So for example, I might do something like this. I might say, well, if I give people some kind of text, maybe a page from a book or something like that, and I say, okay, now look at this page and then type it into the computer, maybe caffeine would improve their typing speed. So I'm going to use typing speed as a measure of concentration. And then I can see whether caffeine affects that or not. So basically, this is our experiment. We're going to compare typing speeds of people after drinking caffeine and after not drinking caffeine. Now the variable that we're going to change in the experiment, this first one, caffeine versus no caffeine, is called the independent variable, or sometimes we call it the predictor variable. And the variable that we're going to measure is called the dependent variable, or the outcome variable, and that's the typing speed on the computer. So we're looking at the effect of the predictor on the outcome, or the independent variable on the dependent variable. In this case, it means the effect of caffeine versus no caffeine on the typing speed. One way you can remember this, I think predictor and outcome is pretty easy to remember, but independent and dependent variable, the dependent variable depends on the independent variable. So the typing speed on the computer depends on whether you have had caffeine or not. Now, this is our basic experiment, but there are other variables that might affect our outcome. For example, the amount of caffeine. We want to control this variable by making sure that everyone who does our experiment gets the same amount of caffeine. Also, the time after they take the caffeine, after they drink the coffee. we need to control that. And we learned from our previous research that it peaks at 1 hour after you drink it. So let's decide that we're going to make them do the typing test 1 hour after drinking the caffeine. Some other things that might affect our results, thinking that you drank coffee, the placebo effect. So the way we can control this variable is instead of using coffee versus water, we can just use like regular coffee versus decaffeinated coffee. And that way the subjects won't know whether they're drinking caffeine or not. Another thing that we learned from the previous research is that people who regularly drink coffee, people who drink coffee every day, caffeine affects them differently than people who don't drink coffee. We need to make sure, we have basically two choices here. Either we can only choose one kind of person to participate in our experiment. We can just get regular coffee drinkers or just get people who never drink coffee. Or we can ask everyone whether they do or not, and then that becomes another predictor variable. Okay, other things that might affect the result that we need to be careful about: computer and the keyboard. So we make sure everyone uses the same type of computer, same type of keyboard. Individual differences. Some people naturally will type faster than other people. So the best way to control this is to have each person do both the caffeine and the no caffeine tests. Now, another problem is the order of the tests. For example, maybe the first time they do the typing test, they'll be slower, and the second time they get used to it, so they get faster. In order to take that into account, we'd have to randomize it. Half of the people will get the caffeine one first, and half of the people will get the decaffeinated one first. Other things, the time of the day, morning or night, and recent meals, make sure everyone has no breakfast or whatever, but as long as everyone does the same thing. Also the environment, we need to make sure that the room, that some people don't do the test in a noisy room and other people do it in a quiet room. All the conditions should be the same for all the participants. And also the age of the participants and the gender might have a role. Okay, so to review, these are our predictor variables, our independent variables: caffeine versus no caffeine, or regular coffee versus decaffeinated coffee, and a regular coffee drinker or not. So people who drink coffee every day versus people who don't. And this is the dependent variable, or the outcome variable, what we're going to measure, the typing speed on the computer. All these other variables need to be controlled so that they don't affect the outcome in a way that confuses our results and makes it so that we don't clearly understand what our results mean. Now we can make our testable question. Instead of "does caffeine help to improve people's concentration?" we can now say, does drinking regular coffee versus decaffeinated coffee affect a person's typing speed on a computer? And then our next step is to make a hypothesis. A hypothesis is basically what you think the outcome of the experiment will be. So we use information that we learned from previous research and put that together to come up with our best hypothesis. And in this case, here's what I think. From reading the other papers, I think regular coffee drinkers, now that regular coffee drinkers means people who drink coffee every day, will have lower typing speeds after drinking decaffeinated coffee. But basically, everything else will have no effect. Now we're ready to actually do the experiment. That's the next step, to collect the data. So collecting our data, there's a few things we need to do here. Usually, we need to get permission for our study from the university. Then we need to test our experiment to make sure it works. It's always a good idea to try it out before you go collect 50 people and have them do it. Then we need to do that, recruit the participants, make sure they understand the purpose of the study and that they volunteer to participate in it. Then we have the participants actually do the experiment. And then finally, doing it, we record our data carefully. And now we're ready to go to the next stage, to analyze the data. So here's an example of a graph of the results of this coffee research. By the way, this is not real data. I just made this up. But if it was real data, you can see that basically my hypothesis was correct. The non-coffee drinkers basically have no difference between decaf and regular coffee. And the regular coffee drinkers, their typing speed is lower when they drink a decaffeinated coffee, but it's not really different when they drink regular coffee. And then finally, we come to the last step, which is to report our findings. And the way we do this is either writing a research paper to submit to a journal, or we do a presentation at a conference, or maybe we do both. Okay, so that's it. Just to review the 6 steps: come up with a research question, do background research, construct a hypothesis, collect data with an experiment, analyze the data and draw conclusions, and then the last one, don't forget to report your findings.